Hello and welcome to Double Angle Identities Part 3. I'm starting with an example that says solve cos 2x equals sine x plus 1, and we want you to solve over the domain from 0 to 2 pi. Alright, so I look at this and I realize I'm going to have to do some sort of a trig substitution on this guy. Okay, I can't have a cosine of a double angle mixed in with a sine of a single angle. It's just, I got to get that so that they're all kind of the same kind of trig functions. So the logical choice for this swap here, okay, is to bring one in that involves only sine of x. So the swap I'm going to use is 1 minus 2 sine squared x. Now what that does, you can see that the unknown, as it were, I got a sine squared and I got a sine x. Well, this is starting to look a little like a quadratic equation. In fact, why don't I bring everything over to the right side and see what I got. Okay, so I'm going to subtract 1 from both sides, and then I'm going to add over the 2 sine squared. Okay, so here's what I got. It is a quadratic equation. And I can actually solve it, I think, quite easily by factoring out a sine x. You could also use a quadratic formula if you wanted to, but I always think factoring is easier, in my opinion. Okay, so I got sine x times 2 sine x and then plus 1. All right, so I have two things that come out of this that I can now use to solve. Either sine x itself could equal 0, or I could have 2 sine x plus 1 equal 0. Now this one is pretty easy if you use the graph, right? If you picture your sine graph, zipping along here. Now remember, I'm not allowed to include 0 or 2 pi, because there's no little equals lines here. So there's only the one point where sine equals 0, and that's at pi. So there's one of my answers. X is pi. Now this one over here, well, let's bring the 1 over and divide by 2. So sine x equals negative 1/2. I'm thinking special triangles again. So, special triangle. So we got a 1 and a 2 and a root 3. And the sine would be this angle up here, right, to get 1 over 2. So I know my reference angle is pi by 6, but I got to put it in the correct quadrants because I want sine here to be negative. So according to the cast rule, that means I got to be in this quadrant and this quadrant. So I'm going to build pi by 6 down here in this quadrant and pi by 6 in this quadrant. Okay, so the first one is pi plus pi by 6. So that answer would be 7 pi by 6. And then this other one over here, well, it's like saying 2 pi, and then you back it up or subtract pi by 6. So that's 11 pi by 6. And those are my 3 answers for this first example. Okay, I'm going to stop with that and move on to my final example. And this one's very, very short. It says to solve the following. And it's also the last example of the chapter. So it's just to show you one little trick that sometimes creeps up. Okay, I look at this and I go, oh boy, this looks an awful lot like the old double angle of sine identity, but I'm not supposed to have a 6 in front. So here's a neat little trick. Why don't we just switch it up and do this? Change our 6 into 3 times 2 times sine x times cos x. Okay? Now the 3, if you want, you can divide it into the 0 into the other side, or you can just leave it. This is what's important though. I can now think of that as sine 2x. I want that to become 0. I want it to equal 0. So now I can solve this equation here. So I'm going to do it as follows. Sine of what equals 0. And I think I'm going to use my graph for this. Okay, there's our sine graph. So I go, oh yeah, bing right there, bing right there, and bing right there. It seems at 0, at pi, at 2 pi, 3 pi, 4 pi. So in other words, I would want this to equal a multiple of pi. Now, I got to fix that up, right? Because actually what I'm trying to solve is not sine of unknown equals 0. I got sine of 2x equals 0. So what effect is this 2 having? Well, it's taking my whole answer, well, my whole graph actually, and scrunching it up by a half. So I got to go 1/2 times my answer. So my answer is going to be n times pi over 2, where n is any integer. And there you have it. So that is the end of this example, and it's also the end of the chapter. So we'll see you in the next chapter.